I'm Eric Lanask. We're here in Santa Clara, California for our Editors' Days. Joining me in the studio now is Eric Dresselhaus from Silver Springs. Eric, thanks for joining me.
Hey, thanks for having me.
So a lot of talk. I mean, I've had several conversations the last couple of days around IoT and what's going on. One thing that I really want to get to is what's going on with IoT and M2M when it comes to sort of critical infrastructure and the networks that have to be managed to enable those smart critical infrastructure, smart cities, and those sorts of things.
Yeah, sure. Well, a lot is happening, is the short answer. If you look across the whole range of IoT applications, there's a lot of people interested in doing wearables and healthcare and things. We really focus on that critical infrastructure part, and I think that's one of the more exciting and frankly, one of the fastest growing parts of the market. The business needs for cities to improve the quality of life, improve the efficiency, both from an energy perspective and from an operating perspective. What was the last city that said, I have too much money, my budget's too big? And on the utility side, energy prices are rising. In the developing world in particular, people are trying to figure out just how to meet the energy needs of their consumers. Mm-hmm. And in a lot of markets here in California, Hawaii, and markets overseas, they're wrestling with real challenges around how they do integrated renewables. And so IoT for critical infrastructure can be a huge part of what makes all of those business needs better.
So, how does Silver Spring Networks play into this?
So we don't build, we don't build the things. We don't build streetlights. We don't build electricity meters. We just build a networking platform that's designed to support this wide range of different applications. And what's different about this platform than a lot of the other IoT kind of networking technologies is that we deal with some of the most stringent customers on Earth. So from a security and a reliability perspective, these are people that have a near mil-spec-like expectation. Critical infrastructure can be underground, it can be behind a vault. So networking those devices, securing them across a 40-year threat model are some of the challenges that we've had to wrestle with for more than 10 years now.
Interesting. You've been doing this for 10 years. What's changed over that 10 years, or more than 10 years?
Oh, a lot. First off, the awareness from the market's perspective has certainly gone from, say that again, to, hey, I need it and I need it now. But the other thing is, you can look at what happens in the evolution of these markets as the confluence of Metcalfe's law and Moore's law. Mm-hmm. So what we can do from a processing power perspective now is so much more than 10 years ago for a certain price point. And the diversity and the number of different devices we can connect is, orders of magnitude more than it was 10 years ago.
What are the challenges that you face when, or what are the challenges that the cities or the utilities or the municipalities face when they're building out these networks?
Well, a lot. Again, the first one is just connectivity. You've got a utility here in Northern California. We're very privileged to team up with Pacific Gas and Electric. They cover 70,000 square miles of service territory. Dense urban environments like San Jose or San Francisco, but also the middle farmlands. This is a geography that's bigger than Great Britain, right? They have 5.5 million customers, and their expectation is that they can get to everybody in the dense urban parts of the city and out to the farmlands, and they all have to be connected in real time. So that's a really tough network problem to go solve. A cellular guy can put up towers and say, hey, I've got coverage everywhere, but if the coverage isn't so good here, step outside to the hallway or go outside the building, you get coverage. I was noticing right before we started that here in this conference room in the heart of Silicon Valley, I don't have cell phone coverage. So if there was a piece of critical infrastructure, or a meter or a control point for the grid sitting right where we're sitting today, cellular wouldn't work.
So how do you help address that?
So we use a technology, 802.15.4G, open standards-based technology that's known as YSUN. We create a mesh network, so all of the devices can talk to all of the other devices, so we can relay messages through any other connected piece of infrastructure. So this really creates a massive kind of distributed computing network, where all of the devices can speak to each other pairwise, across the network, up and down the network. And what we find is you can go to the toughest RF environments around, and you'll get connectivity by leveraging the density. A lot of networks say, if you get too big, you say, whoops, that's getting to be a problem. I'm going to run out of capacity. with a mesh network like we provide, that actually is the exact opposite. Meshes love density. The more devices, the better.
What about security when it comes to the mesh network? Are there specific threats that you have to keep in mind? Are there specific places in the network that are less reliable?
Well, not less reliable, but you're absolutely right. You really do have to think about security in a different way. A lot of old networks that were built, people only worried about the security kind of at the edge of the network. So all the things that were happening downstream, I didn't really care about those so much, and I would just try to secure the connection back into the back office. We can't work off that expectation. Every device has to be equally secure to each other as well as to the network. So what that means is not just kind of 256-bit AES encryption and all of the normal things, but hardware security modules on every communications module. Driver's licenses, birth certificates that are burned in at manufacturing, and keeping that root certificate all the way through to a system that's going to be operating in the field for 20, 30 years or more. So it's a very complex security management and upgrade process.
So Eric, you've seen this happen going on for a little over a decade. Where do you see the company and the networking that you help deliver in the next several years?
The short answer is more. What we see happening now is because these ubiquitous, secure, reliable networks are available, the number of new devices, new applications that are coming on and are becoming available to our customers is just kind of going through the roof. So examples include things like traffic control, signage in the streets. Environmental monitoring is something that we get a lot of requests from cities. They want to put up CO and NO monitors throughout their city to monitor air quality, which is a big citizen concern. So one big thing we see is that the diversity of these devices is going up and up and up and up and up. Another thing that we are seeing is that the market dynamic, this started really in North America. This was our first big market.
Sure.
Then Europe kind of caught on. Asia, Brazil, developing markets are now at least as interesting and as interested in the technology. It's that kind of famous leapfrog technology where people didn't have any phones and they never put out copper. They just jumped right to cell phones. We see cities that have pretty poor infrastructure. They can't keep the lights on for 20 hours a day, let alone 24 hours a day, using this technology as a way to kind of get caught up. So we see the global market as a big part of the driver going forward.
So you said it a little while ago yourself that we haven't found a city yet that says we have too much money. How do they budget for all this new technology? Certainly can't be a cheap venture.
Yeah. Well, a lot of what we find is some of the things in automating and upgrading your street lighting is a good example. The payback scenario for a city that uses kind of old sodium lights and upgrading to new LED lights that now have controls is a really amazing payback. That's a kind of typically sub 2-year payback for a city. So that pays for itself.
Sure.
As a side benefit of that, now you have a ubiquitous networking infrastructure that goes across the city, and so the marginal cost of, say, adding traffic onto it is pretty low. So we see this as not, the budget process really isn't a problem. It's actually almost one of the drivers and the enablers to doing it.
Gotcha. Sounds exciting. Sounds like a lot of fun. A good place to be.
Yeah, a lot of fun, a lot of work.
Excellent. Eric, thank you so much for joining us.
Hey, thanks for having me.